Let's talk about the clustering algorithm in machine learning, especially used for unsupervised machine learning. So if you haven't watched the supervised versus unsupervised machine learning, there's a card on the top of this video and you can go and watch it. So clustering algorithm mainly is used in the unsupervised machine learning, and the main goal is to to identify the natural grouping or clustering within a data set without any prior knowledge of the labels or classes. Here you only have the features and there are no labels which are available to you. The top use cases for clustering algorithm are these customer segmentation, image analysis, anomaly detection, etc. Now, let's talk about how this clustering actually works. So, since we already know that the intent of the clustering algorithm is to identify the groupings and patterns, because we do have the availability of the features, but we do not know the label. For example, if we are talking about e-commerce website, we might have data about lot of customers on how they are purchasing, what they are purchasing, but we do not know about the customer themselves. So we just know the customer purchase history. Now our main aim is to identify the pattern among this data that we have and be able to get some insightful data out of it. So now if I talk about how clustering algorithm work, there are certain steps which are followed for this. So the first step in the clustering algorithm is the data presentation. So the data that we have is presented in a suitable format. For example, feature vectors. So here each data point is described by a set of features or attribute that capture its characteristics. So we do not have the labels here, but the data is uh, set as a set of features or attributes, and then that is sufficient to talk about its characteristic. Second step, once you have already represented the data, second would be to calculate the similarity or dissimilarity between the data points using a distance metric. For example, a Euclidean distance or Manhattan distance or cosine similarity. So these are some of the methods through which you can actually do the distance measurement. And this choice of distance metric actually depends on the nature of the data, first of all, and then what type of problem are you solving. So this is what we do. We have different data, so we just try to find the similarity or dissimilarity between each of these data points. Third step is to initialize, where initialization actually talks about the creation of clusters, the initialization of cluster. So here we talk about the initial position of the cluster from where the cluster will actually start. And depending on the algorithm, which one you're using, be it k-means or it can be, let's say, optics, it can be Birch, a lot of different algorithms are there. So these initial centroids, we call them centroids, may be randomly assigned or determined be specific using to a specific initialization technique. So here you define where the your cluster actually starts from. What is the initial position of the cluster? Then if we move ahead from here, then in the fourth step, we have assignment where each data point is assigned to the cluster with the nearest centroid. So we already know that there are so many data points and we are trying to find the similarity and dissimilarity between them. So we are assigning the cluster with the nearest centroid based on the similarity or the distance measure. So for example, there is this initial centroid and the other data point have similarity between them. So wherever the similarity is, that goes into the formation of the clusters, right? Now, since your cluster formation has started, the next step is the iterative refinement. Here, clustering algorithm iteratively refines the cluster by updating the position of the centroid and reassigning the data point based on the new centroid position. So this process goes on till the convergence criteria is met. For example, the maximum number of iteration or when centroid no longer moves significantly. So that is where you already have talked about the refinement. Next is the cluster evaluation. Since the cluster has been formed, it has been mature. Now you would like to evaluate the quality of the obtained cluster. You see if it includes the some of the evaluation methods are in measurement of the Silhouette score, cohesion, separation, and internal clustering validation indices. These are some of the ways you can measure it. And these measure assess how well the data points within the cluster are similar to each other while being dissimilar to the data point in another cluster. So the cluster should not be coinciding, they should be separate. And the last step is the cluster interpretation. So once the cluster algorithm has already produced the cluster, you have done the evaluation. Now it is important to interpret and analyze the result. Of course, any machine learning algorithm that you follow, you always look out for some sort of insights in the end. So this is the stage where you do the interpretation of the data. So of course, this may include the visualization of the cluster, or you're exploring the characteristics of data point within each cluster, or let's say applying a domain specific knowledge to understand the meaning and implication of the identified cluster. So this way, the clustering algorithm in machine learning, does a lot of things in terms of pattern recognition, as well as when we talk about certain more aspects of the data, those grouping and clustering are formalized. Now, if I talk about the popular clustering algorithms, there are a lot, but three popular clustering algorithm that I would like to talk about next is k-means, hierarchical clustering, and db scan. Thanks for joining. I'll see you next time.